Hey everyone, welcome back to the channel. Today, we're diving into essential Python control structures like if-else branches, detect equality branches, detect range branches, relational operators, logical range detection, basic ranges with gaps, multiple distinct if statement, membership and identity operator, order of evaluation, and conditional expressions to write smarter, cleaner code. First, we discuss the concept if-else branches. If else branches are a fundamental concept in programming that allow you to make decisions in your code. They enable your program to choose between different paths based on certain conditions. Let's break down the if else branch concept using a real world scenario, like a restaurant host seating guests. The host needs to decide where to seat guests based on the size of their party. For example, if a party of one arrives, the host seats them at the counter. If a party of two arrives, they are seated at a small table, and larger parties, consisting of three or more people, are seated at a large table. The host follows a mental algorithm. If the party size is 1, they seat them at the counter. If it's 2, they seat them at a small table. And if it's 3 or more, they seat them at a large table. This decision making process mirrors an if else structure in Python, where the program checks conditions and executes actions based on whether they are true or false. In this example, the concept of an if branch is demonstrated using a hotel discount based on age. A hotel may offer a discount only to guests over the age of 65. The program follows a simple decision making process. First, it checks whether the user's age meets the condition greater than 65. If the condition is true, the first branch executes, applying the discount to the hotel rate. For instance, if the user's age is 68, the condition 68 greater than 65 is true, so the discount is applied, lowering the rate to 135. If the user's age were 50, the condition would be false, so the second branch executes and the hotel rate remains at 135. After the condition is checked and the appropriate branch is executed, the program continues with the subsequent statements, outputting the final price. In this example, the concept of an if branch is used to compute the absolute value of a number. The absolute value of a number is its distance from zero, regardless of whether it is positive or negative. The program follows a decision making process. If the number is less than 0, the branch executes and the program multiplies the number by negative 1 to make it positive. For instance, if the input number is negative 99, the condition negative 99 less than 0 is true, so the program will multiply negative 99 by negative 1, resulting in 99. This is a clear example of how an if branch can be used to modify values based on specific conditions, ensuring the result is always a non negative number. In this example, the program uses an if else branch to determine an insurance price based on the user's age. The condition checks if the user's age is less than 25. If the condition is true, meaning the user is under 25, the program executes the first branch, setting the insure price, to 4,800. However, if the user's age is 25 or older, for example 26, the condition is false, and the second branch executes, setting the insurance price to 2,200. This demonstrates how an if else branch allows the program to choose between two different actions, pricing in this case, depending on the result of a condition. In this example, the program uses an if-else structure to detect the specific value of the variable num years and respond accordingly. The program first checks if num years is equal to 1, and if true, it outputs newlyweds. If the condition is false, the program moves to the next condition. It checks if num years is 25, and if true, it outputs silver. If neither of the first two conditions is true, the program checks if num years is 50, in which case it outputs golden. If none of the conditions match, the final else branch executes, providing a default response. This structure allows the program to evaluate multiple possible conditions and execute the appropriate action based on the value of num years. Now it's time to put your knowledge to the test with some practice questions. Take your time to think through each one, then share your answers in the comments to show that you understand how if else branches work. Don't just sit back, dive in, and demonstrate what you've learned. Here comes the first question. If the branches were rearranged to check for x equals 1, x equals 0, and then x equals negative 1, would the output still be the same? Think carefully and decide what do you think would happen. Choose the right answer from the options below and let's see if you've got it. Share your answer in the comments. Let's see who can figure this one out. Here comes the second question. If x is set to 1, what will the program output? Choose the right answer from the options below and let's see if you've got it. Take your time and think it through. Take a moment to go through your answers carefully, one by one. Reflect on what you've learned and let us know in the comments how many you got right and how confident you feel about your understanding of the concepts. Now move to the concept detect equality branches. In programming, detecting whether two items are equal is a frequent requirement. This task is commonly achieved using an if statement combined with the equality operator. Consider a program designed to calculate a discount on hotel rates for couples celebrating their 50th wedding anniversary. The program begins by assigning a standard rate of 150 to the variable hotel rate. It then prompts the user to input the number of years they have been married, storing this value in the variable num years. If the user inputs 50, the condition num years equals 50 evaluates to true, triggering the execution of the if block. Within this block, the program applies a discount by halving the hotel rate, acknowledging the couple's golden anniversary. Finally, the program concludes by printing the updated hotel rate, reflecting the discount. This example demonstrates how an if statement can be used effectively to detect equal values and execute specific actions based on the outcome, showcasing its utility in real world programming scenarios. Equality and inequality operators compare values in a program, returning true or false. Equality checks if values are the same, while inequality checks if they differ. These operators are essential for decision making in programming. This table illustrates the behavior of equality and inequality operators. The equality operator checks if two values are equal, such that A is equal to B evaluates to true if A equals B. For example, if x is equal to 3, the result is true, but if x is equal to 4, the result is false. The inequality operator checks if two values are not equal, meaning B evaluates to true if A does not equal B. For instance, if x is not equal to 3, the result is false, while x is not equal to 4 yields true. An if-else statement allows a program to execute one group of statements when a condition is true and another group of statements when the condition is false. In this example, the program determines whether a number entered by the user is even or odd. The if statement checks if the remainder of dividing the number by 2 is 0, indicating the number is even. If true, the if block executes, otherwise, the else block executes. For instance, when the user enters 22, user num%2 evaluates to 0, making div remainder equal to 0. Since the condition div remainder equals 0 evaluates to true, the if block executes. Conversely, if the user enters 45, user num%2 evaluates to 1, and div remainder is set to 1. The condition div remainder equals 0 then evaluates to false, so the else block executes, indicating the number is odd. Now that we've covered the concept of detect equality branches, let's see how well you've grasped the concept. I've got a few quick questions for you. Think about the questions and give your answers in the comments for me to review. Here's your first challenge. If x is 5 and y is 7, what do you think the result of the expression x equals 5 will be? Take a moment and make your guess. Time for the second challenge. How do you think the expression x equals y will evaluate? Think it through and share your answer. Here's your third challenge. If y is 7, how do you think the expression will evaluate? Take a moment to think and let us know your answer. Review your answers carefully. Compare them with the concepts you've studied, and let us know in the comments how many you got right and how confident you are in your understanding. Next, we discuss the concept detect ranges branches. In programming, Detecting range branches is a common technique used to determine whether a value falls within a specific range and to execute corresponding actions based on that range. Consider a soccer club that organizes teams based on age groups. The program uses an if else structure to assign kids to appropriate teams. First, the club excludes kids aged 5 or younger, as no teams exist for them. Next, the under 8 team is for kids aged 6 or 7. Similarly, the under 10 team is for kids aged 8 or 9, and the under 12 team is for kids aged 10 or 11. No teams are available for kids aged 12 or older. An if-else structure elegantly captures these ranges. Each expression only needs to check the upper limit of the range, as the program knows that all previous conditions are false. The flowchart illustrates how a multi-branch if-else structure is used to detect age ranges and assign an insurance price based on the user's age. The process begins by obtaining the user's age, user age. If the age is less than 16, the output displays too young with an insurance price of $0. If the age is between 16 and 24, the insurance price is set to $4,800. For ages between 25 and 39, the price is reduced to $2,350. Finally, if the age is 40 or older, the insurance price is set to $2,100. Each branch executes sequentially, ensuring only one range condition is met, and the corresponding price is displayed as the annual price in the output. The decision making structure ensures clarity and precision by leveraging the sequential evaluation of conditions. Now it's time to test your knowledge. Let's see how well you grasp the concepts we've covered. Think carefully and type your answers in the comment section for me to review. Ready? Carefully review your answers and compare them with the concepts you've studied. Share in the comments how many you got right. Next, move to the concept relational operators. Relational operators are fundamental tools in programming used to compare two values or variables. These operators return a Boolean result, either true or false, based on the relationship between the compared values. The table illustrates the four common relational operators and their respective meanings. The less than operator checks if the left operand is less than the right operand. For example, x4 evaluates to true when x is 3, but x3 evaluates to false since the values are equal. The greater than operator verifies if the left operand is greater than the right operand. For instance, x2 evaluates to true when x is 3, but x3 evaluates to false because the value is not greater. The less than or equal to operator checks if the left operand is either less than or equal to the right operand. For example, x less than equal to 4 and x less than equal to 3. Both evaluate to true when x is 3, but x less than equal to 2 evaluates to false. The greater than or equal to operator ensures the left operand is either greater than or equal to the right operand. For example, x greater than equal to 2 and x greater than equal to 3 evaluate to true when x is 3, but x greater than equal to 4 evaluates to false. These operators are essential for implementing decision logic in programs, enabling conditions to determine the flow of execution. Programmers often use the sequential nature of multi-branch if-else statements to detect ranges of numbers. In this example, the second branch expression is only evaluated if the first expression is false, enabling precise range detection. For instance, if user age less than 16 evaluates to false, the program proceeds to check the next condition, ensuring the value lies within a specific range. In the first step, the user enters 27 as their age, which is stored in memory as the variable user age. The multi-branch if-else begins by checking if user age is less than 16, which evaluates to false since 27 is greater than 16. In the second step, the next branch checks if user age is less than 25. This condition also evaluates to false because 27 is greater than 25 25th. In the third step, the program evaluates whether user age 40, which is true since 27 falls within this range. Consequently, the elif statement executes and the variable insurance price is set to 2350 in memory. This example demonstrates how multi-branch if-else structures efficiently identify number ranges and perform specific actions based on the detected range. Now that you understand the concept, let's put your knowledge of relational operators into practice. Work through each question carefully, and remember, accuracy is important. Share your answers in the comments for feedback. Here's your first question. If numdogs is greater than 10, what operator will you use to complete the expression? Here's your second question. If numcars is 5 or greater, which operator completes this expression? Here's your third question. Since lost has gone below 0, which operator fits perfectly to complete this expression? Dive in and figure it out. Here's your fourth question. For Namishkas to be 5 or more, which operator would make this statement complete? Take a moment to consider this and drop your answers in the comments. Go over your answer and match it with the concept you've studied. Share in the comments if it's correct and how certain you are about your understanding. Next, we discuss the concept logical range operators. Logical range detection is a powerful method to evaluate conditions in programming using logical operators. Logical operators treat operands as either true or false and evaluate expressions accordingly. The most commonly used logical operators are and, or, and not. Logical operators are frequently used to determine whether a value falls within a specific range. For example, the range 10 x 15 includes the values 11, 12, 13, and 14. In a program, this range can be specified using two comparison operators combined with AND operator. The condition 10 x establishes the lower bound, meaning x must be greater than 10, starting from 11. Similarly, x 15 establishes the upper bound, meaning x must be less than 15, ending at 14. Combining these conditions with the AND operator ensures that both conditions must be true simultaneously, thus narrowing the range to the overlapping values 11, 12, 13, and 14. This approach allows programmers to precisely define and evaluate ranges in their code. A Boolean is a data type that can hold one of two possible values, true or false. These are fundamental keywords in Python and must always be written with an initial capital letter. Booleans are essential in programming as they are commonly used in conditional statements and logical operations. A programmer can assign a Boolean value directly by using the keywords true or false, or by evaluating an expression that results in a Boolean. For example, the assignment myBool true sets the variable myBool to the Boolean value true. Similarly, the expression is small for 3 evaluates whether 4 is less than 3. Since this condition is not met, the variable is small is assigned the value false. This illustrates how Boolean values can be derived from logical expressions to control program flow and decision making. This table highlights the three fundamental logical operators in Python and, or, and not, which are represented using the lowercase keywords and, or, and not. These operators are crucial for evaluating complex conditions in programming, especially within conditional statements like if else. The AND operator evaluates to true only when both operands are true. If either operand is false, the result is false. The OR operator, on the other hand, evaluates to true if at least one of its operands is true and only results in false when both operands are false. Lastly, the NOT operator inverts the value of its operand, producing true if the operand is false and vice versa. These logical operators enable programmers to construct intricate decision making logic by combining multiple Boolean expressions effectively. This table illustrates examples of logical operators with the given variable values age 19, days -7, and user char q. The first example evaluates to true because both conditions are true age 16 and age 25. The second example evaluates to false because although age at 16 is true, days 10 is false, and both operands must be true for the AND operator to yield true. The third example evaluates to true because at least one operand, age 116, is true, satisfying the OR operator's condition. In the fourth example, not days 10, evaluates to true because the operand, days 10 is false, and the not operator inverts it. Similarly, not age 16 evaluates to false because age 16 is true and not inverts it to false. Lastly, not evaluates to false because the operand is true and not flips it to false. These examples demonstrate how logical operators function to combine or negate conditions effectively in Python. These examples demonstrate how logical operators function to combine or negate conditions effectively in Python. After discussing the concepts related to logical range operators, let's test your understanding with some practice questions. Think carefully about the questions and share your thoughts in the comment section below. Here's your first challenge. Imagine we've got two numbers, x is 7 and y is 9. Now we're combining two conditions with an a in the operator. The question is simple yet exciting. Will this entire expression evaluate to true or false? Time for your next challenge. We're working with the same values. Now, the OR operator takes the stage. The conditions are x10 and y20. Remember, with OR, only one condition needs to be true for the whole expression to be true. Here's the third challenge. In this question, we've got x is 7, and we're applying the not operator to the condition, x to 10. Remember, not flips the result. So, what will it be? Will it evaluate to true or false? All right, here's your fourth challenge. We're still working with x as 7 and y as 9, and this time we've got a more complex expression with the AND operator inside a not. Take a moment to evaluate AND part first, then apply the not. What do you think? True or false? Review your answer and see how it aligns with the material you've studied. Let us know in the comments if it's correct and how confident you are in your grasp of the topic. Next, we move to the concept basic ranges with gaps. Basic ranges with gaps are value ranges that include distinct, non overlapping groups separated by intervals, gaps, where no specific condition applies. These gaps represent portions of the range where the values do not fall into predefined categories, requiring separate logic to handle them. For instance, a movie theater might offer ticket discounts to children and seniors while charging the highest price for everyone else. This type of logic can be implemented using an if else statement to detect and handle such ranges. In this example, the user enters their age and the program evaluates it step by step. First, the program checks if the user's age is 12 or less, applying the child discount if true. If not, the program moves to the next branch, which checks if the user's age is 65 or older. For a user age of 67, this condition evaluates to true, and the senior discount is applied to the ticket price. If neither condition is met, meaning the age falls between 13 and 64, the program defaults to the else branch, charging the full ticket price of $14. This example demonstrates how an if else statement can be used effectively to handle ranges with gaps, ensuring each range is addressed appropriately. Ranges with gaps can be effectively managed using logical operators, enabling programmers to detect values within specific bounds while accounting for gaps. For example, if valid office numbers fall within the ranges of 100 to 150 or 200 to 250, the logical and operator can define each range explicitly. Numbers that do not meet either condition fall into the gaps between the ranges. By combining these conditions using the OR operator, both ranges are seamlessly covered in a single logical expression, simplifying the code and ensuring all valid ranges are accounted for efficiently. Now that you've grasped the concept of basic ranges with gaps, it's time to put your knowledge to the test with some practice questions. Take your time to think through each question, and please share your answers in the comments below. Here's your first question. Seniors get a special ticket discount. What's the age range for this? Think carefully and choose wisely. Here's your second question. Take a look at the code snippet. The last branch uses an else statement which catches any remaining cases. What do you think the range for this branch is? Go through your answers and compare them with the correct one. Share in the comments how many you got right and how confident you feel about your understanding of the material. Now, let's discuss the concept. Multiple distinct if statements. Multiple distinct if statements allow a program to evaluate several independent conditions, where each if statement is checked individually. In this program, the variable user age is initialized to 26, though it could be replaced with user input for flexibility. The program consists of multiple distinct if statements, each checking a different condition based on the user's age. The first if statement checks if user age is less than 16, but since 26 is greater than 16, it evaluates to false and does not print the message, enjoy your early years. The second if statement evaluates whether user age is greater than 15, which is true for 26, so it prints you are old enough to drive. The third if statement checks if the user is older than 17, which is also true, so it prints you are old enough to vote. The fourth if statement checks if the user is older than 24, and since 26 satisfies this condition, it prints most car rental companies will rent to you. Finally, the fifth if statement, which checks if the user is older than 34, evaluates to false for 26, so it does not print the message about running for president. The result is that three messages are printed, reflecting the true conditions: driving, voting, and renting a car. This demonstrates how multiple independent if statements can be used to check several conditions and execute multiple blocks of code simultaneously when those conditions are met. In this program, the variables user choice and num items are hard coded with the values 2 and 5, respectively. The first step evaluates whether user choice is equal to 1 using an if statement. Since user choice is 2, this condition is false, so the program moves to the next branch, the elif statement, which checks if user choice is equal to 2. As user choice is indeed 2, the program enters this branch and proceeds to the nested if-else statement. Inside the elif block, the program checks if num items is less than 0. Since num items is 5, which is greater than 0, the program moves to the else block, which prints the message user choice is 2 and num items greater than or equal to 0. If num items had been less than 0, the program would have printed a different message indicating that num items was negative. The program then completes execution after printing the output for this case. Thus, the program demonstrates the use of nested if else statements, where one if else condition is placed inside another, allowing more specific conditions to be checked in a structured way. All right, after discussing the concept of multiple distinct if statements, it's time to test your skills. I'll present some questions, and I want you to think carefully about your answers. Here comes the first question. Imagine you have a certain number of apples, and you're trying to figure out how many boxes you'll need. Start with num apples, there are 9, and follow these conditions carefully. What do you think the final value of num boxes will be after both conditions are applied? Think you've got it figured out. Here comes the second question. With num apples equals 12, you need to evaluate these conditions to determine how many boxes are needed. Let's see if you can work through the logic and figure out the final value of num boxes. Carefully check your answers and match them with the correct answers. Share in the comments how many you answered correctly and how confident you feel in your understanding. Next, we explore the concept of membership and identity operators. Membership operators are useful for checking whether a specific value exists within a container, such as a list, tuple, or dictionary. Consider a scenario where a list is used to demonstrate the concept of membership operators. First, a user creates a list containing several numerical elements. The list is then used to check if a specific value, such as 15, exists within it. Since 15 is found in the list, the expression evaluates to true. Next, the user checks for the presence of 44 within the same list. As 44 is not found in the list, the expression evaluates to false. This example highlights how membership operators streamline the process of searching for values within containers in Python. In this example, the program demonstrates how the membership operators in and not in are used to check if a specific item exists within a list. First, the program uses the in operator to check if a user's input, a name, is present in the Barcelona FC roster list, which contains the names of players like Alves, Messi, and Fabregas. The program prompts the user to enter a name and checks if it is in the list. If the name is found, the program outputs a message saying, "Found name on the roster." If the name is not in the list, it outputs, "Could not find name on the roster." Next, the program demonstrates the opposite check using the not in operator. In this case, the program checks if the input name is not in the list. If the name is not found, it prints the message "could not find name on the roster," and if the name is found, it prints "found name on the roster." This example illustrates how the in and not in operators allow for easy checking of membership within a list, making it a powerful tool for tasks like searching and validation in Python programs. In this example, the program demonstrates the use of the membership operator in a dictionary. The dictionary MyGedict contains keys A, B, and C, each associated with values 1, 2, and 3, respectively. The first check uses the in operator to verify if the key B exists in the dictionary. Since B is a valid key in the dictionary, the program prints "found B." This illustrates that the membership operator in dictionaries specifically checks for keys, not values. The second check shows a common misconception. It attempts to check if the value 3 exists in the dictionary using the in operator. However, the membership operator in this case only checks for keys, not values. Since 3 is a value associated with the key C but is not itself a key, the program prints 3 not found. This example highlights the distinction that the membership operator checks for keys within a dictionary, not the values. In this example, the program uses the identity operators is and is not to check if two variables point to the same object in memory. The variables w, x, y, and z are assigned values, with w set to 500, x and y both equaling 1000, and z being assigned the value of x. The first check confirms that z and x refer to the same object in memory, as both are bound to the same value, printing z and x are bound to the same object. This illustrates how the is and is not operators evaluate whether two variables are referring to the same object, rather than merely comparing their values. Now it's time to test your understanding. Let's see how well you can apply what you've learned about membership and identity operators. I'll ask you some questions, and I want you to think carefully before you answer. Share your answers in the comment section for me to review. Here's the first challenge for you. How would you check if X is a key in the dictionary myDixT using the simplest Python expression? Think you've got it? Here's your next challenge. How would you express that the variables X and Y are distinct objects in Python? Think carefully before you answer. Here's your third challenge. How would you check if the character G exists in the string myStr? Take a moment and let's see if you can figure this one out. Check your answer and determine how well it aligns with the concepts you've studied. Share in the comments if it's correct and how certain you are about your understanding. Now, let's explore the concept order of evaluation. In programming, the order in which different operators in an expression are evaluated is determined by precedence rules. These rules govern the sequence in which operators are processed, ensuring that expressions are evaluated correctly and consistently. The order of precedence in expressions dictates the sequence in which operators are evaluated, ensuring that the expression is processed correctly. First, parentheses have the highest precedence, meaning any operations inside them are evaluated first, no matter what other operators may appear outside. Following that, arithmetic operators come next. This means multiplication, division, and modulus operations are performed before addition and subtraction, ensuring that calculations are handled in the proper order. After arithmetic operations, relational and equality operators less than equal to, greater than equal to, and not equal to are evaluated, which are used for comparing values and checking for equality or inequality. These operators are processed after arithmetic operations but before logical operators. Among logical operators, logical not has the highest precedence, so it is evaluated first. This operator negates a condition, flipping its truth value. Next, logical and is evaluated, which is used to combine multiple conditions. ensuring all must be true for the overall expression to be true. Finally, logical or has the lowest precedence, meaning it is evaluated last. This operator evaluates to true if at least one of the conditions is true, combining multiple conditions where only one needs to be true for a true result. Understanding these precedence rules is crucial for interpreting complex expressions accurately. In the example, the concept of applying precedence rules to an expression is illustrated as a tree structure. Initially, the expression involves several operators, such as addition, greater than, multiply, equal to, and or. According to the precedence rules, the multiplication operator has the highest priority, so y multiply z is evaluated first. In this case, with y as 6 and z as 3, the result is 18. Next, the addition operator comes into play, and x plus 1 is evaluated, resulting in 8. After that, the relational operator is evaluated, comparing 8 and 18, resulting in false. The equality operator is then evaluated, with z equal to 3, which is true. Finally, the logical or operator is evaluated last, combining the results of false and true, which ultimately evaluates to true. This step by step evaluation follows the precedence rules, with each operator being applied in order from highest to lowest priority, ultimately producing the final result of true. By thinking of this process as a tree, we can better visualize how each part of the expression is evaluated from the bottom up. After discussing the concepts of order of evaluation, let's test your understanding with some practice question. Think carefully about the questions and share your thoughts in the comment section below. Here's your first challenge. In the expression, which operator do you think takes the highest priority? Here's another challenge for you. In the expression not y and x, which operator is evaluated first? Here's your last challenge. In the expression, what's the correct order of evaluation? Take a moment to consider how the operators stack up. Let's see what you think. And match your answers also. Share your answer in the comments. Review your responses and check how well they align with the concepts you've learned. Let's dive into the concept of conditional expressions. Conditional expressions provide a concise way to evaluate conditions and return one of two possible values depending on whether the condition is true or false. The example demonstrates the use of a conditional expression as a concise alternative to the traditional if-else statement. In the first step, the if-else structure is transformed into a single line conditional expression. In the second step, the condition in the middle of the expression is evaluated first. If the condition evaluates to true, the expression on the left is executed and its value is assigned to the variable my_var. Conversely, in the fourth step, if the condition evaluates to false, the expression on the right is executed and its result is assigned to my_var. This streamlined approach highlights how conditional expressions enable concise and efficient assignment of values based on a condition. Alright, after discussing the concept of conditional expressions, let's put your understanding to the test. Think about the questions carefully and comment your answers in the comment section. Let's see who's nailed it. Here's a challenge for you. Can you convert this if else statement into a clean single line assignment using a conditional expression? Here's your next challenge. Take this if else block and simplify it into a single assignment statement using a conditional expression. Remember to wrap the condition in parentheses. Think carefully and write your answer in the comment section. Examine your answer and check how it corresponds to the concept you've learned. Share in the comments if it's correct and how confident you feel about your understanding. In this journey through Python, we've explored the essential building blocks that form the foundation of logic and control in programming. From understanding basic operators and conditional expressions to mastering complex concepts like membership and identity operators, each step has enriched our knowledge of how to write clear, efficient, and powerful code. We've learned to apply precedence rules, structure our decisions with if else and nested statements, and handle containers like lists and dictionaries with ease. Whether you're checking for membership in a list, comparing objects with identity operators, or optimizing your expressions with conditional logic, these tools empower you to craft smarter solutions. Now, with these concepts in hand, you're ready to take your programming skills to the next level, tackling challenges with confidence and creativity. If you enjoyed this tutorial, please like, comment, and subscribe to our channel. See you in the next video.